Hey everyone. In this video, we're building a smooth, swipe-based onboarding experience in SwiftUI. The user scrolls through full-screen videos with seamless transitions and subtle animations that feel polished and responsive. We'll cover how to loop background videos, layer gradients, track drag gestures, and snap from one screen to the next. Along the way, we'll also dive into the logic that makes it all work, handling offsets, scroll boundaries, and smooth movement. If you're building a modern, scrollable intro for your app, this is a great foundation. Let's get started. In this part, we're building a looping video player that can play short intro clips without stopping. It uses UIKit under the hood, wrapped nicely for SwiftUI. This way, we can play videos like MP4-inch, the background of our views, and as soon as the video finishes, it restarts automatically, creating a seamless loop with no interruption. This is great for an immersive experience, like fitness intros, product showcases, or any cinematic moment. This view adds a soft gradient overlay with a cool rounded shape. We're repeating the shape 3 times using for each with a bottom rounded style that gives it a nice smooth look. Now, the important part is the gradient. It fades from transparent at the top to a custom color at the bottom, and it sits on top of those rounded shapes. Then we use scale effect to control the direction. If from bottom is true, the gradient stays normal. If it's false, we flip it vertically. That way, we can use the same view for both top and bottom overlays, just flipped when needed. It's clean, reusable, and adds that nice soft fade effect to the layout. We've got a Get Started button here, big, bold, rounded, and wrapped in a nice gradient. The text sits at the top, giving it that call to action feel. Now, maybe you're wondering why we're using .overlay instead of a Z-stack. Good question. It's actually about how everything moves. When the user drags the screen, we want the entire button, including the text, to move together smoothly. If we use Z-stack, the text might feel disconnected or lag a bit, because it's technically outside the main view's layout flow. With .overlay, the text becomes part of the button's layout, so when we animate or drag, it all moves as one, no weird delays or glitches. We're setting up a simple data model to represent each video card. It holds the video file name, a title, and a short description. This makes it super easy to loop over and build each view dynamically clean, organized, and ready for scaling if we ever want to add more content later. So final offset is kind of like our anchor point. It keeps track of where we are in the scroll, which view we're currently on. We'll use it to know whether we should go to the next screen or back to the previous one. For example, if the user swipes up past a certain point, we'll subtract from final offset to shift to the next view. And don't worry, we're going to break this down even more soon. We'll explain how final offset, current drag, and last view all work together to handle scrolling, animations, and detecting the last screen. It's all connected, and once you see it in action, it'll click. Current drag is all about tracking the user's finger while they're dragging. As you swipe up or down, this value changes in real time. It doesn't move the view permanently, it just shows the live motion. Later, when the user lets go, we'll check how far they dragged. If it's enough, like more than 100 points, then we'll decide to move to the next or previous screen. So current drag is like a preview movement, and final offset is the permanent shift. You'll see soon how they work together to create that smooth, snapping behavior. Last view helps us figure out when we've reached the end of the scroll. It's like a boundary check. If we're on the last video, we might want to change what the button says, slow down the drag, or even show a final message. We'll calculate its value based on how many videos we have and the height of each screen. That way, we know exactly when we've hit the last one. It gives us full control over the flow and the user experience at the end. We're using Geometry Reader here to get the screen size super helpful because it lets the layout adapt to any device, whether it's an iPhone SE or a giant iPad. Inside, we're calculating image height by dividing the total height by 1.2. That gives us about 80–85% of the screen for the video or image, and the rest stays open for other elements like padding, buttons, or extra views. This way, the layout always feels balanced, no matter what screen you're on. We're looping through all the videos using for each and indices. That just means we're working with the index of each item 0, 1, 2 instead of the object itself. Why? Because having the index helps us customize each screen based on its position. For example, we can show a continue button only if we're not on the first view, or detect when we're at the end. It gives us a lot more flexibility for layout and logic. Here's where we actually show the video. We're using looping player view to play the clip, giving it full width and the height we calculated earlier. Then we clip it with rounded corners to match the smooth, modern look. On top of that, there's an overlay with two main layers, a gradient at the bottom to help the text stand out, and a V-stack with the video title and description. It's centered, bold, and super readable, even over a busy background, exactly what you want for a strong message. If index isn't 0, that tells us we're not on the first screen, so we show the continue button. But instead of showing it instantly, we make it react to how far the user has scrolled. That's where progress comes in. Progress is just a number that represents how deep we've scrolled through the stack of views it increases as we swipe up. Because scroll values are negative in SwiftUI when moving upward, we flip them to get a cleaner, positive value. Then there's is past last, which checks if we've scrolled too far beyond the last view. If that happens, we want the button to disappear completely, so it doesn't just float in space. And finally, we calculate opacity. This is the key to the smooth fade-in effect. We compare how close our progress is to the current index. If we're very close, the opacity is high, the button is fully visible. If we're far, it's low or even 0. We use some helpers like abs to ignore direction, and min and max to make sure the value always stays between 0 and 1, never too bright, never too dim. It's one of those invisible details that makes everything feel more polished, like the button is aware of exactly when you need it. At the bottom, we show the Get Started button using Get Started View, and we give it a dynamic height starting at 250, but we also add the absolute value of current drag. That means the more the user scrolls, the taller it gets. This is intentional. It gives a little stretch effect, making the button feel reactive. But more importantly, it signals that we've reached the end, this is the final screen, and the button is here to take the user forward. It's not just a button anymore, it's a transition moment. We use offset Y and will be final offset plus current drag to move the entire stack of views up and down based on the user's interaction. Final offset holds the current position of the scroll where we left off, and current drag adds the live movement while the user is dragging. By combining both, we create a smooth, natural scrolling effect that follows the finger exactly and then locks into place when the drag ends. It makes everything feel fluid and connected, like you're really pulling each screen into view. And since both values are animated with .smooth, the transition always feels soft and polished. Before we start with gestures, let's take one step back. We're going to pause here and look closely at three things: final, offset, current drag, and last view. These values are the foundation of how the whole scroll interaction works. So before jumping into the gesture itself, let's understand what each one does and how we'll use them to control movement, direction, and logic across the views. As you know, we've used indices in the for each, and that gives each view a number starting from 0. So the first screen is index 0, the second is 1, the third is 2, and so on. This index is really useful. It tells us exactly where we are in the scroll and lets us control the layout based on position. For example, we can use it to decide when to show a continue button, when to change behavior at the end, or even just to display which screen the user is on. It's a small number, but it drives a lot of the logic behind the scenes. The first thing you should know about current drag is how it behaves based on the direction you scroll. If you're dragging down, it gives us a positive number, and that usually means you're on the first view, because there's nothing above to go to. On the other hand, if you're dragging up, it gives a negative number, which means you're trying to go to the next view below. This difference helps us understand the user's intent and decide whether we should move to a new screen or bounce back. So now that we know how current drag gives us direction, here's how we use it in practice. If the user swipes to the bottom, meaning the value is negative, and it's more than -100, we treat that as a clear intention to move to the next screen. So we push the view up. If the user swipes upward, which gives a positive value more than 100, we push the view down back to the previous screen. But if the drag is smaller than 100 inch either direction, it means the gesture was too light or accidental, so we simply return the view to its original position. It's all about reading the intention behind the swipe and responding with purpose. So let's talk about final offset. The height of each image or video isn't taking up the full screen. We're dividing the screen height by 1.20. which means we're using about 80 to 85% of the screen. On this device, the iPhone 16, that gives us a view height of 738 points. Now here's how we use that. If the user swipes to the bottom and the drag is more than -100, we update final offset by adding -738. That pushes the whole view up, showing the next screen. And if they swipe upward with a drag greater than +100, we add +738 to final offset, which moves everything back down. Returning to the previous screen, it's a step-by-step scroll system, controlled by how far and in which direction the user swipes. We can use both final offset and current drag to understand exactly where we are in the scroll. If final offset is 0, that means we're on the first screen we haven't swiped anywhere yet. So if the user tries to swipe down, we know they're trying to go above the first view, which doesn't exist. In that case, we slow things down intentionally. We divide the drag to make it feel heavier and less responsive. It's a subtle way to tell the user, there's nothing above here, without needing any message or warning. It just feels right. So let's talk about last view. This value helps us figure out when the user has reached the last screen. We're working with 3 screens, and since we're using indices, they start from 0, so we have screen 0, screen 1, and screen 2. Each screen takes up 738 points in height, so we can figure out their positions by multiplying the index by 738. That means the first screen is at 0, the second at 738, and the third, which is our last, is at 1,476. That's the number we set as last view. It acts like a limit, so we know when the user is at the end of the scroll. And just like we did on the first screen, if the user tries to scroll past the last one, we slow things down to give that soft resistance. It's a small detail, but it makes the interaction feel more controlled and polished, like the app understands exactly where you are. Now we're setting up the gesture. We start with a drag gesture, and we set the minimum distance to 0. That just means the gesture will respond immediately, even if the user only moves their finger by 1 point. Without this, sometimes short drags wouldn't be detected, and the view would feel unresponsive at the beginning of the swipe. So this tiny line makes the whole interaction feel faster and more responsive from the very first touch. Next, we use .onChanged, which runs every time the user moves their finger. This is where we update current drag in real time. As the finger moves, we're constantly adjusting the position of the view to follow it. This makes the scroll feel alive, like it's directly connected to your touch. We're not committing to any movement yet, we're just tracking the gesture and visually following along, creating that smooth pull effect as you drag. Let's take a look at what happens when the user starts dragging. First, we calculate a value called next offset. This is where the view would move if we applied the drag right now, so it's the current final offset plus the user's drag distance. Then we set 2 limits. Max offset, which is 0, this represents the top of the scroll, or the first screen. Min offset, which is the bottom, we calculate that by multiplying the number of screens minus 1 by the height of one screen. That gives us the maximum distance we're allowed to scroll. Now, we check if the user is trying to go too far. If next offset is greater than max offset, they're trying to scroll above the first screen. If next offset is less than min offset, they're trying to scroll past the last screen. In both cases, we apply resistance by dividing the drag by 5. It slows things down and creates a soft boundary. But if the drag stays within the valid range, we allow it to move freely. This way, the scroll feels smooth and natural, but also smart enough to stop where it should. On-ended is the part of the gesture that runs right after the user lifts their finger. So the drag is complete, and now it's time to make a decision. This is where we stop reacting in real time and instead choose what should happen next. Should we move to a new screen, go back, or stay in place? It's like the final response to the gesture, based on how far and in which direction the user swiped. Here, we're preparing to move to the next screen. We start by calculating what the new position would be if we did scroll. We call it next offset, and it's just final offset minus 1, full screen height. Then we check 2 things. First, did the user swipe up more than 100 points? That means they really meant to go forward. Second, are we still within the scroll limit? We don't want to move past the last screen. If both are true, we update final offset with the new value, which shifts the whole view up and snaps to the next screen. It's our way of saying, cool, that was a strong swipe, and there's still more to see, let's go forward. Now we're checking if the user swiped down more than 100 points. That means they're trying to go back to the previous screen. If we're not already at the top, We allow it by adding the screen height to final offset, which moves the view downward to the previous screen. But if we are already at the top, meaning we're on the first screen, we just reset final, offset back to 0, so nothing moves. Finally, we reset current drag to 0 to stop the view from following the finger after the gesture ends. That's what makes the animation settle cleanly in place. When the view first appears, we calculate the height of one full screen by taking the total screen height and dividing it by 1.20, which gives us around 80–85% of the screen. We store that value in height, and then use it to calculate last view. We multiply the height, plus 10 for spacing, by the number of screens minus 1, because remember, indexing starts at 0. This gives us the exact position of the last screen, so we know where to stop the scroll and prevent the user from going too far. Thanks for watching. If you enjoyed the video, don't forget to hit the like button and subscribe if you're into building smart projects with SwiftUI. I'd love to hear your thoughts. Drop a comment with any ideas or questions. And see you in the next video.